I would like you to give a very warm welcome to programmer, author, illustrator, and she's much more actually, Linda Liukas.
You pronounced my name perfectly without even me having to cue it in, so good job. My name is Linda. I'm a writer, I'm an author, I'm an illustrator, I'm a very mediocre programmer, so there's probably better programmers in the room here, and I'm a business school dropout. And as you can see, 3 of those identities are in pattern thesis, because I still feel all the time as an imposter and someone who's almost there, except for the business school dropout part that I'm pretty sure about. And that's kind of the topic of this talk today. We people, we contain multitudes. We can be many things at the same time, and that's our power. Computers, they are one thing or the other. I'm the co-founder of Railskills, a non-profit movement that teaches young women programming, also in English, even though the text here is in Finnish. It gives young women their first experience in software craftsmanship in over 260 cities around the world, everywhere from Amman to Australia and Belo Horizonte to Berlin. I worked at Codecademy, a massive online open community that teaches people programming, 25 million people programming all over the world. And after Codecademy, I felt a little bit jaded with all of the startup ethos in the world, and I felt that, oh wow, like the most important things in the world can't be decided by startups, and there's bound to be something bigger and more meaningful I can do with my life. And in the same way as Astrid Lindgren, the author, the Swedish author, said that the world peace starts from the children's room, from the children's bedroom, I felt that, wow, if we really want to have scalable change in the world, we need to start from the very smallest of us. So everyone here in the audience working in education, I have a huge respect for you. And I decided that I will be a children's book author. I had absolutely no idea how to do this, and I did the best and the worst thing I've done in my life. I put my little tiny side project on kids and coding to Kickstarter, where it ended up gathering $380,000 worth of pre-orders in 30 days, and I absolutely panicked because I had no idea what I was doing. And for the past 2 years, I've been a children's book author. The book is finally now out, also in Dutch. And this is kind of a lesson and a journey in what I've learned about programming, coding, education, and maybe about life too. In the true format of a children's book, I'm going to tell this story in 4 little chapters. And when I was thinking about how to tell this story in particular, I came to the wise person, my favorite storyteller of all time, namely Lewis Carroll, who beautifully combines logic and magic and is probably the role model for us today on how to creatively teach technology. And Carroll has this famous line of believing in 6 impossible things before breakfast. So I would like you to turn your heads into the impossibility state and follow with me through the rabbit hole. I think software and code is the interface to my generation's imagination. I think we live in a world that is becoming computers, and the scariest thing of all is that we make computers seem either boring, mechanical, or magic, and all of those 3 things are really bad. So in this first chapter, we'll start from the very beginning of the story and try to sort of go through how computers then ought to be taught. And to get started with this story, we need to start from where the best stories in the world always start from, namely from love. And this was a very specific type of love. This was a teenage girl's love. And I was 13 years old, and my teenage girl heart was nearly pumping out of my breast because I had a huge crush on an older man. Other girls, they loved Legolas, and they loved Elijah Wood. Lord of the Rings was really big at the time, and they loved gothic rock stars. But I loved the Vice President of United States, Mr. Al Gore. And I had this scrapbook about him. I had it everywhere with me, and at some point the pictures weren't enough. I wanted to express all of this love a little bit bigger and further and massively, so I made a website for him, and it's here. And this was 2009, so 2001. So there was no Facebook, there was no Tumblr, there was no Pinterest. The only way a teenage girl could express all of the excitement and love was by learning to code. So I learned PHP, and I learned HTML, and I learned CSS, and I learned how servers work. And when this site was up, I felt, wow, technology is the thing that I want to do in life. This is amazing. But there were other boys. There were other things to get excited about, like knitting and philosophy and social sciences and French. Like studying French was a big thing for me at the time. And I started to feel that, oh wow, like maybe this technology stuff, it's pretty boring and pretty lonely and pretty introverted, and it's only for the smelly teenage boys over there. And I forgot about coding. Here's what I think today. I think little girls, they don't know that they are not supposed to like computers. They are really smart. They are really precise. They can concentrate so well. They are really good at asking questions like how and why and what if. And they don't know that they are not supposed to like computers. It's us parents who do. It's us adults who say that, oh, like, you're probably a girl who doesn't like computers. You're really good with languages. You should study French. And they fail to notice that a little girl who liked conjugating French irregular verbs was actually practicing her pattern recognition skills, a crucial thing when you're programming. A little girl who liked knitting socks was actually following a sequence of symbolic commands with loops inside of them, like follow this line until you hit the elbow. And a little girl who loved Bernard Russell and his eternal quest to find an exact language between English and mathematics, which eventually would be called logic and eventually would find its home inside of a computer, would totally make a good programmer. No one made those connections. To some extent, the parents are right. There's an awful lot of things you need to understand even before you can write your first hello world. There's syntax, control flow, data structures, algorithms. We've built abstraction on top of abstraction to the point where we, as consumers, we have no idea how computers work anymore. When our kids come to us and say, hey, Linda, how does the computer know what to show when I press the play button on YouTube? Or, Linda, what is bubble sort algorithm? Or, Linda, is internet a place? We adults, we grow silent. We say, oh, it's really complicated. Or, oh, wow, it's magic. Well, it's neither. It's not magic and it's not complicated. It all just happened really, really fast. And our kids, they are surrounded by this world of technology. They tap and they swipe and they pinch their way through the world. And unless we are willing to give them a totally new kind of education around computers, we are failing as adults. I think in the same way as when we teach Dutch, we don't only teach punctuation rules. We don't only teach grammar, like conjugation. We teach them to use the language. We teach them to write poetry, really bad ones. And we teach them to write essays. We read contemporary novels and classics. We teach them to use a language. And that's what we should be doing with technology. So chapter 2, where we look a little bit further into what I mean when I talk about having this different way of teaching technology, having a shared vocabulary into programming. I've talked to you a little bit about Ruby. She's the heroine of the book. She's 6 years old. She's completely fearless, a little bit bossy, and very imaginative. And in Ruby's world, things that sometimes are boring in classroom are taught through play and exploration. So in Ruby's world, the curriculum of code might look like this, where the idea of repetition, the idea that a computer is really good at repeating things, it doesn't get bored, it likes the tedious stuff, it doesn't need lunch breaks. A perfect way to teach this concept, for instance, is through dancing. And Ruby's favorite dance move, it goes like this. It goes clap, clap, stomp, stomp, clap, clap, and jump. And we learn a for loop by repeating this sequence 5 times. And we learn a while loop by repeating this sequence while I'm standing on one leg. And we learn an until loop by repeating this sequence until mom gets really, really frustrated. In Ruby's world, you learn decomposing problems. You learn to look at different kinds of problems and see how to solve them. For instance, Android has clearly forgotten to do one step in the progress of making a bath, and the fox has done something in the wrong order, and little Ruby, she has something funky happening in the loop because she keeps on eating even though she's not full, and so forth and so forth. And finally, kids learn about algorithms. Whoa, what a big, hard word, at least for the adults. But kids, they are so proud when they learn algorithm. And they learn that an algorithm is actually a step-by-step step-by-step instruction to solve a problem. So for instance, a cupcake recipe is really an algorithm, and good algorithms are ones where you can swap ingredients. For instance, if you want to make banana muffins instead of blueberry muffins, and then you want to make different amounts of cupcakes. But the most important thing the kids learn is that even the biggest problems in the world are just tiny problems stuck together, and this is the most important thing I've learned from CS, or computer science. I think the reason why we want to be teaching these things for kids is not that we would want to have a cadre of programmers ready to march into the corporations and work there. We want to teach these things because all problems in the world will be computer problems that need a human flair to be solved. We want kids to understand these are the problems that a computer can solve. These are the problems that a human can solve. And we want kids not to be afraid of computers. We want more kids who embrace technology. So chapter 3, where we start to get more concrete. I'm really jealous for those of you who were born in or who went through the education system in the 60s and 70s. You might not believe me, but you had this tangible relationship with technology. You had transistor radios that you could take apart. Nowadays, you can have 1 million transistors in the end of a pen point. And there's no way to understand how technology works. Everything is sleek and glassy and hidden from us. And it might be that you hated the programming lessons you did in school, the basic programming or the weird calculus exercises you did with the teleprompter. But at least you got to see how the computer worked and use it as a problem-solving machine. My generation, we learned to use Microsoft Office, and that's that. And I think the education system should take a step further and really think what is joyful in programming. In my opinion, there's 2 types of joys. There's the more abstract joy, the joy of writing a really complex algorithm or I don't know, abstracting a function call properly. And that's the type of joy you kind of have in the AP computer science classes. You write programs to calculate the first 20 or the square roots of the first 20 prime numbers. And that is really suited for certain types of kids. But if we want to teach computing and programming to all types of kids, we really need to broaden the joy to different kinds of kids. And at least for me, my joy in programming comes from copying and pasting things together and seeing, oh wow, like this might work or it might not work. Let's try, run and compile, and boom, it solved my problem and I made the computer obey my will, and that feels amazing. And that's joy, and that's play, and that's what I was after. So I tried to figure out who in the world knows plays best, and I went to Lego, and they had this wonderful chart about different motivations for a play. They talk about achievement-based motivation, social motivation, and immersion-based motivation. And for some reason, whenever we talk about playfulness in the educational system or gamification, we talk about this little column here. We talk about progress, we talk about power, we talk about optimization and challenging others and numbers and leaderboards, when in reality, everyone in this room who's ever programmed knows that there's so much more. There's the joy of helping each other. There's the joy of giving support to other people. There's the joy of exploring different possibilities of solving a problem and coming up with different solutions. And there's the joy of hiding from real-world problems and coming up with storylines and characters. And I think we should be embracing all of these different types of playfulness if we want to teach coding to all types of kids. The kids who learn by doing this, and the kids who learn by listening, and the kids who learn by reading, and embrace all of those different types of learning skills. And in chapter 4, we're going to look at a few different examples of this. In some of the workshops we do, we start by having this discussion about what is a computer, and I show kids these 4 pictures. I show them a picture of a car, a dog, a grocery store, and a toilet, and I ask them, which one of these, in your opinion, is a computer? And the kids, they look at me and they think, oh, she's not wise because none of this is a computer. Are you stupid? The computer is the glowing box in front of which mom or dad spends way too much time. But then we talk, And we realized that, maybe a car is a computer because a car has a navigation system. And maybe a grocery store has different kinds of computers, like the ice cream box, something that keeps the ice cream from not melting, and the teller machine or the burglar alarm systems. And maybe a dog is not a computer, but maybe a dog's collar has a computer inside of it. And a lot of kids immediately suggest that, what if the car is the dog is a robot? And I'm like, yeah, a dog robot, that's really cool. How it's different from the machine. And then I tell the kids that in Japan, toilets are computers, and there's even hackers who hack them, and I'm always the most popular person among the 6-year-olds by this point. And then we move on, and I give them these little stickers with an on-off button on them. We are in a regular room with regular household appliances, and I tell them that, kids, for this afternoon alone, you have a magic ability to make anything in this room into a computer. And again, the kids object. They say, that's too hard. I don't know the right answer for this. And I tell them that, hey guys, neither does your mother or father. They've just heard about this thing called the Internet of Things or the IoT. But you guys are going to grow up in a world where your toothbrush is a computer, and your teddy bear is a computer, and your washing machine is a computer, and it's kind of up to you to design that world. So what we end up doing is the kids make little computers, and I had this little girl who took this bicycle lamp, and she came to me and said, hey Linda, this bicycle lamp could be a computer and it would change colors. And that's really good, but are you now really using all of the things a computer can be? And she goes back and she thinks, and then she comes back to me and very proudly tells, okay, if this bicycle lamp were a computer, we could go on a biking trip with my father. And then we could go sleep in a tent, and in the evening, this bicycle lamp could also be a movie projector. And that's the moment I'm looking for. The moment when the kid realizes 3 very profound things that us adults have a hard time understanding. First of them is, the world is not ready. We live in a world that is progressing all the time and getting better and better. The second thing is that technology is a really amazing way to make the world better, whether it's by doing business or doing art or doing sciences. And finally, that they themselves can be a part of that change. And the odds are that the little girl will not be the next Steve Wozniak or the inventor of the bicycle lamp movie projector. But for a moment there, she felt empowered and like that could be a career choice of hers. And that's what we should, as educators and parents and adults, guard in childhood. So how should we talk about computers and what they are for kids if computers are not the glowing boxes? It's really funny how the abstractions of computing and the models of computing we use come from 1945, where everything else in the world has changed, but the model we talk about when we talk about computers. Because you see, John von Neumann, he's a famous computer scientist, and he designed the von Neumann architecture in, I think, 1945, and it goes like this. Whenever kids ask me, so what is a computer if a computer is not the box anymore, I tell them, well, a computer is anything where you put in data, something happens to the data, and something new comes out. And what makes a computer so special is that it has memory, and it has 2 types of memory. The first type of memory is the memory that remembers the data that comes in and then what comes out. But the second type of memory is the special one, because that's the instructions on what to do with the data. That's called software, and programmers are ones who write the software. And that makes a computer so potential, because a tractor can be a tractor, and a pinball machine can be a pinball machine, but a computer can be anything based on what you decide to do with it. And at this point, kids usually are like, oh, you're talking too theoretical, let's do something. So we build a computer, and the kids crawl into the computer, and there's little instructions for them, like come out crawling backwards, or come out crawling, jumping on one leg, and then the other kids need to decode what was the code that went inside of the computer. So they learn input, process, output, and eventually they run around the computer so much that it breaks. So that's that. The kids also get to draw what is inside of a computer in their opinion, and it's really fascinating to see how differently kids approach these things. So there's the linkers, the kids who understand computers as abstraction, as something, boxes that are somehow connected to one another, very adult thinking. There's the gear gurus who think that a computer has some sort of gears, something mechanical inside of it happening. And then there's my favorite ones, the drafters, the kids who understand that there's electricity inside of a computer and that it's based on logic, not magic. It's based on different kinds of components talking to one another, and these kids are going to have a bright future. And finally, the kids get to build their own computer out of paper. They get to know the bossy CPU that gives instructions to all of the other components but has a hard time remembering anything. So it needs the help of the RAM and the ROM. And they look at where their summer vacation photos go to and so forth and so forth. And then they design their first applications. And my favorite story of all time is this little boy whose favorite thing in the world is to be an astronaut. And the boy, he sits on the opposite side of the room with these huge headphones on. And his dad, really the astronaut in the lone Martian atmosphere, is on the opposite side of the room, and the boy is the mission control man, and he's designed intergalactic planetary navigation application. And his role is to bring the father safely back from Mars to Earth. And I think these kids will have a profoundly different experience of what it is to create with technology and what it is to program and use the boring computer of the yesteryear. Almost final chapter. What does this mean for schools and educational systems? I think one of the very scary realities is that we've outsource technology education to companies. I think especially the teachers in the room should reclaim technology education back to you, because we as technology people will come up with a gazillion different kinds of apps. And I'm not saying that screen time is evil or all of the time spent in front of a screen is bad. What I'm saying is that I bet many of the teachers here in the room have seen this list, like 50 new tools to teach you coding, or 20 new ways to use Google more effectively in your classroom. But these things lack depth. These are superficial solutions to very small skill sets. And I think we need the teacher's experiences and principles underlying. And the good news is that the whole history of computer science is full of multidisciplinary people. We needed biology, we needed physicists to come up with heating solutions. We needed material scientists to create transistors. We needed mathematicians, we needed philosophists, we needed graphic designers and sociologists to imagine the future where we are going to live in. And in my work, I feel like I'm most inspired by the work they did in the 70s, imagining the future of computing. And basically, Alan Kay in the 70s, he imagined the next iPad, like a hackable version for kids that they can open up, and he was considered totally lunatic at the time. And Alan Turing in the 50s, he started the discussion about the child machine, so the concept that a computer, instead of sort of cramming artificial intelligence into it, what if we raised computers as kids and taught them to learn, learning to learn being the key word. And then Seymour Papert and Cynthia Solomon have this wonderful paper about 20 things to do with computers that outlines 20 things you can do with computers to teach practical skills for a kid and creative things. So it's kind of very lately that we've had this mechanical and boring and sort of corporate view of what computer science education should look like, that is driven by the politicians and GDP growth and all these things that don't mean anything for your little students. I think it's almost time for us to realize what John Dewey dreamed of, having a classroom be the democratic world and raising kids for the society that have those experiences of building practical things. And when John Dewey lived, it wasn't possible to do this with technology. It was possible to do project-based work in humanities, but technology had to rely on abstractions and simulations and rhetoric and models. But now we're getting closer to the time where we can actually have kids build things with 3D printers and with programming and simulate things and concepts that are hard to see otherwise. And another example comes from the early 19th century with Montessori pedagogy that might be, I've heard that it's very popular here in Netherlands. Maria Montessori definitely understood something very profound about how kids learn and what's the best way of doing things. So what if we build our computer science curriculum around principles this deep and this broad? And final educational example is Reggio Emilia, the Italian schooling system that starts by saying that a child has 100 languages. They form their whole pedagogical thinking around a poem, and the poem says that a child has 100 languages and 100 ways of exploring things, but we adults say that there's one way of thinking and one way of solving problems. And Reggio thinks that sculpting and painting and singing and math, they are all ways of children's languages, and I'm thinking coding might be one of those languages for the future too. So what should this look like in classroom then? What can we design if we decide to take these approaches that the pedagogicians in the room recognize so well, but as technologists don't necessarily always know? I think we could be teaching kids programming through phenomenon-based learning. We could be teaching them in context and showing them real-world examples of how the things they are doing affect their world. And say if we're teaching them recycling, we could start by talking about what is recycling, but we could move then on and think about, okay, so how it's going to affect the world if computers help us recycle things. And that's a very natural pathway into learning about different kinds of sorting algorithms and different kind of data structures and so forth and so forth, when you give context and when you give meaning for the kids. Finally, I think less and less I'm trying to teach kids about programming, because programming is just one tool to solve a problem. It's a really important and a really big tool, but more and more I feel like we are teaching and preparing kids for a world where everything around them will be a computer, and understanding that technology is part of us. It doesn't belong to someone else. There's no binary world where you need to be a technology person or a non-technology person is one of the key things. We need nurses who understand the power of computers. We need policemen who code. We need biologists who understand data structures, and so forth and so forth. Final chapter and one of the biggest sentences in the history of children's literature. And the best advices in life that I've gotten from C.S. Lewis: when you're faced with a problem, begin from the beginning and keep going until you hit the end. And that's that. I think the more approachable and fun and exciting and context-driven we make the world of technology, the better world we'll have. And technology inherently is built on humanity. The first computers in the world were humans who were calculating things. It used to be a profession to be called a computer. And technology, it doesn't include only the tools to solve a problem. It also includes the attitudes and skills and mindsets, all very human things. And I think the biggest barrier for this world is us adults. Because when you talk with kids, they get this stuff already. I talked with 9-year-olds. I asked 150 of them, what is technology? Who uses it, and what is it used for? And this is one of the answers I got. This is a 9-year-old girl who said, technology is electricity that loves. That was her definition of technology. Electricity that loves. And she keeps going and says that we use technology with mom, with WhatsApp, and technology used for play, and people uses technology. And that makes me really optimistic about the future. I'm not scared about artificial intelligence or robots taking over the world, because I feel like I have power over them because people use technology. So imagine with me a world where the tiny Ada Lovelaces of the future feel empowered to drive this change. A world where the 20-something-year-olds of the Silicon Valley bubble don't decide what kind of problems should progress and get better and be solved. A world of technology that is wonderful and whimsical and a little bit weird. Thank you.